All right, today you are going to be working on two-step equations. By the end of our time, you need to be able to solve two-step equations with showing all of your work. As we prepare to show our work, please pick up a graphic organizer from the folder and label it Solving Two-Step Equations. Now this week we've already been solving one-step equations. Just a reminder that as we do our work, we need to isolate the variable. We need to get that all by itself. And as we get that variable by itself, we need to continue to use the inverse operations. As we show our inverse operations, we need to remember the golden rule for solving equations. That states that whatever we do to one side of the equation, we are going to do to the other. Please make sure you are showing this in your work today. On your graphic organizer, you will see the steps at the top there that are telling you what to go through in order to solve for your variable. Please make sure that you are drawing the line through the equal sign, splitting that problem into two parts so that we can clearly see your inverse operations that help isolate the variable. When you isolate that variable, please make sure that at the final part of your solution, you do check your solution by substituting your answer back into the equation. Now, just as a review here, please write what the inverse operations are on your graphic organizer. I'll give you a couple of seconds to do that and then remind you what they are. Remember that anytime we see adding, we are going to subtract to take that away. If you see subtracting, we're going to add to take that away. And if we see multiplying, we are going to divide to cancel that out. Vice versa, if we see dividing, we are going to multiply to cancel that out. Now, as we take a look at our two-step equations here today, I'm going to go through three examples for you. Please copy these down in the appropriate example box as I go through the work. So, if I'm following those steps that are listed at the top of my graphic organizer, I'm going to draw the line to show the two sides that I have to remain equal to each other. And whatever I write on the left side of that line, I'm going to write on the right side of that line. So, we remember that we normally work in order of operations. If we are undoing our work, we are going to work backwards. So as I look at this, I first want to undo adding or subtracting, and then I want to undo multiplying or dividing. So if I look at my problem here, 3x minus 4 equals 17, I'm going to add 4 to both sides. And when I add 4 to both sides, on the left-hand side, the 4's cancel out, and I am left with 3x. On the right-hand side, 17 plus 4 equals 21. So my equation now shows 3x equals 21. This is a one-step equation like you've previously solved, so we should be able to go through that. But right now I see that I have multiplying 3 times x. So to cancel that out, I'm going to divide by 3. If I divide by 3 on both sides, I get x equals 7. Now to check that, I would take 3 times 7 minus 4. 3 times 7 is 21. 21 minus 4 is 17, which is the answer clear up here. So I know that x equals 7 is correct. If I take a look here at example number 2, I notice that I have 3 equals n divided by 5 plus 8. Again, please put that work in the example 2 box. I'm going to draw my line here to show my two sides. And if I remember, I'm going to be undoing adding or subtracting and then multiplying or dividing. So I see I have plus 8 here. I want to subtract 8 from both sides. If I do that on the right hand side, I'm still left with n divided by 5. On the left-hand side, I need to be careful here. I have 3 take away 8. That's not possible, so I should know that I'm going to end up with a negative number. So I get negative 5. Now if I take a look here, I still do not have the variable by itself. So if I have n divided by 5 here, I need to multiply by 5 over 1 to cancel out the 5 in the denominator. If I do that, I get n over 1, which is just n, and I must multiply by 5 on the other side, and I get negative 25. So if I check my work here, I have negative 25 divided by 5 plus 8. That needs to be able to give me 3. Well, negative 25 divided by 5 is negative 5, plus 8 is positive 3. So I know that I am correct. Okay, the third and final example here before you're going to be able to try some on your own. Please remember to copy this down once again in the third example box. I'm going to draw my line here. Now before I get started, I want to take a look here. I have 9 times x minus 9 equals 72. So I'm going to add 9 to both sides first. On the left hand side, those 9's cancel and I get 9x equals 81. I see that I have multiplying here, so I'm going to divide by 9 on both sides. 9 divided by 9 is 1, so 1x is just x, equals 81 divided by 9 is 9. So x equals 9 is my answer. I'm going to check my work here. 9 times 9 minus 9 needs to give me 72. So I have 81 minus 9, and that does equal 72. So I know that I am correct. All right, the first independent practice here. Go ahead and copy these 6 problems down, please. After you have copied them down, go ahead and keep the video paused until you need the answers. After you finish, you will find the answers provided before you find another set of problems to solve by yourself. All right, so the answers here, if we take a look at number 1, we have 1/8 m minus 2 equals 18. So I'm going to draw my line. I'm going to add 2 to both sides, and we get 1/8 m equals 20. So now this 1/8 m looks a little bit different. In order to cancel out that fraction, I do want to multiply by 8 over 1. That cancels out that fraction. And I'm left with m, which is the whole reason why we're solving. We want to isolate that variable. So I'm going to multiply by 8 over here. 8 over 1, or just 8. And I get 160. So my answer here is 160. On number 2, you should have subtracted 11. Notice that there is not a sign in front of that 11. So that means it is positive. So I subtract the 11 from both sides. They cancel out, and I get 3m equals 21. Divide by 3, and you should have gotten m equals 7. Number 3 here. Draw that line. You want to add 10 to both sides. You get 30 equals 5x. I have multiplying, so I'm going to divide by 5 on both sides, and we get 6 equals x, or x equals 6. Doesn't matter which way you write that. Okay, the next 3 problems and final problems for this set. Take a look here at our answers. We want to first add 2 to both sides here for number 4. When we do that, we get y over 6 equals 5. Now remember, y over 6 is a dividing problem, so to cancel that out, to do the opposite, we want to multiply by 6 over 1. If we do that, that cancels out our 6's, and we are left with y equals, and then I multiply by 6 over here, and I get 30. So y equals 30. Okay, number 5, draw that line. Notice that I have adding and multiplying, so I know I'm going to be subtracting and dividing. So we want to subtract 6 from both sides. I get 4 equals 2x, and we divide by 2, and we get x equal to 2. And the 6th problem here, draw that line. I have adding and dividing this time, so I'm going to be subtracting and multiplying. So I'm going to subtract 2 from both sides. I get 6 equals n over 2, and I must multiply by 2 over 1 to cancel that out, and I get n equals 12. Those are the answers to those 6 questions. If you take a look at this second set of independent practice here, you want to copy those down, okay, and then solve them on your own. After you are done solving, please either raise your hand for your teacher to come check them, or go find your teacher if they are working with someone and ask them to check your problems. Okay. After you are done with those 6 problems here, there are some level 4 questions that are optional, working in with the fractions and decimals, types of rational numbers that we need to be familiar with. So feel free to copy those down, solve them, and your teacher does not need to check that. You can go ahead and put that in the tray for your teacher. Please do attempt some level 4 questions if you want to challenge yourself, and then turn that graphic organizer into the tray or bin or folder that your teacher has for you to place your papers. And you will then be moving on to a different topic next time.